All right, everybody. Here's the first lesson of the last bit of Trig. This is Trig Part 2. I'm writing the notes because I'm going to shorten this a bit instead of using the book, and my book has writing in it, so I can't use the PDF of the book. But we're on page 591. It's lesson number 1, solving first-degree trig equations. And it's just a simple little concept that we're going to introduce here called a general solution. So the first example that they have is sine of x is equal to negative 1/2. And so we did this in the last unit. The negative on the 1/2, if you remember, add sugar to coffee. The negative tells you what quadrant you are in. So sine is positive in the first quadrant and the second quadrant. That means it's negative in the third and the fourth, so that we know we are in the third and fourth quadrant. Then we find the reference angle. Hopefully you remember how to find the reference angle by using the inverse sine function, sine to the -1 on your calculator, of 1/2. Remember, we ignore the negative sign. And that will give us 30 degrees as our reference angle. So that means these two angles here are 30 degrees. So what does x equal? Well, it's the rotation. So to get to there, that is going to be 180. That's 180 plus 30, which is 210. And then to go all the way to there, that's almost to 360. So it's 360 minus 30 degrees, which is 330. Now, if you notice in the equation, they say that your x must be less than or equal to 2 pi, but greater than 0, which means our answers have to be in rads. So we have to convert 210 to radians. Remember, you can just go times pi over 180. Or you can remember that 210 is a multiple of 30, right? 7 times 3 is 21, so 7 times 30 is 210. So 7 times, what's 30 degrees in radians? Hopefully you remember. Pi over 6. So it is 7 pi over 6. If you did it as a decimal and went times by pi over 180, you would get, give me 1 sec here, 0.122. That does not seem right. Because it's not 7 times pi, it's 7 times pi over 6. Sorry, people. Sorry, it's 210 times pi. 210 times pi equals divided by 180. 3.66. That's it. Sorry about that. So that would be 3.66 radians. Those are the same answer. 330 is a multiple of 30 as well. It is 11 of them. So you could just write 11 pi over 6. Or you could multiply it by pi over 180. And you get 5.76. Both of those are the same. Now, here's the new part. Right below it, it says, what is the general solution? So these two answers, 5.76 and 3.66, or 7 pi over 6, or blah, blah, whatever, 33210, are the answers that fit in this domain. But if you remember the sine graph, and hopefully you guys do, the sine graph, sine of x, looks like this. And that's 360, right? And when we say sine x is equal to negative 1/2, what we're saying is we draw the line, do it in a different color. at negative 1/2, it's a horizontal line. Where they intersect are the answers, and these points here are, I'll just do it in degrees, 210 and 330. That's where the intersects are. But if you remember a sine graph, and we've restricted the domain, sorry, to 0 to 2 pi or 0 to 360, so it's just one cycle. But if you remember, the sine graph actually goes on forever in both directions. So you can see it's going to hit at multiple points. To get these points, think about it. To get this point here, that is a multiple of the period, all right? That's one period of the graph, so it's minus, if I went minus 360 degrees, I would get that point because we're going backwards. If I wanted to point out here, I would go, it's going to be off this page, it'd be plus 360 degrees. So the general solution gives you all the answers that are possible if the sine graph goes on forever. But there's an easy way to find it. All you do, and I'm going to do it in degrees here. You take your two answers, 210, 330. So the general solution is going to be 210 plus 330 plus, and it's just multiples of the period. So in this case, n360. n360. What is n? NEI, which means n is a integer. Hopefully you remember what an integer is. It's a plus, that's a positive or negative whole number. So plus minus 1, plus minus 2, plus minus 3, etc. And that's how you get the ones going backwards, the negatives. All right? So the simple way is the general solution is your first answer. And by first answer, I mean this one here, 210, plus n times the period of sine graph is 360 degrees. And your second answer, whoa, sorry about that. And your second answer plus n times the period. That's it, okay? So you just have to remember for sine and cosine, sine x, cos x, the period is equal to 360 or 2 pi over your b value, right? But for this lesson, they will all be 360 degrees. If it's a tan, the period is 180 over your b value. We'll deal with b values in the second lesson. All right, so the only other question I'm going to do, I'm going to ask you guys to skip to page 594. Page 594. At the top, there is this question, 2 cos of x minus root 3 is equal to 0. Solve this and give the general solution. Okay, so solve it normally. Move the root 3 over. So I get 2 cos of x is root 3. I'm going to divide off the 2. Cos of x is equal to root 3 over 2. All right, cosine is positive. Jeez, sorry people. Cosine is positive. So what quadrant are we in? Well, cosine is positive in the first quadrant because everything is positive in the first quadrant. And it's add sugar to coffee, or all students take calculus. Coffee is in the fourth quadrant, so we are positive there. So we're in the first and the fourth quadrant. Find your reference angle. Remember, you use the inverse function, cos to the minus 1 over root 3 over 2, which will give you 30 degrees. So we know our reference angles are 30 and 30. Okay, so what is our rotation? Well, if I start here, boom, that's 30 degrees. So our first answer is x is equal to 30. Our second answer is, what does it take to go all the way to there? It's 330. All right. So there's my two answers. They want the general solution. So all you do is take your two answers, degrees plus n multiples of the period. So n 360 and 330 plus n 360. If they want everything in rads, then you would just go 30 degrees in rads is pi over 6, as we discussed before. 330 is 11 pi over 6 plus n. What is the period in rads? 2 pi plus n 2 pi. So depending on if they want their answer in degrees or radians, that's all you do. All right, we'll do the next two, and then this lesson is over. Really, really short. So the two below it, we have class example number 3. They have sine of x is equal to 0. Okay, so I'm going to show you two ways to do this one. What is my reference angle? Reference angle is going to be sine to the minus 1 of 0, which is going to spit out 0 degrees. So that means you are there and there. There's reference angles of 0. Well, what's my rotation angle to get to the first bit? 0 degrees. To get to there, 180. And to get all the way around to there, it's 360 degrees. So those are your answers. If they ask for the general solution, just take your three answers and add multiples of the period. Period of a sine graph is 360. So it's n 360, 180 plus n 360, or 360 plus n 360. That is completely valid. You could have recognized, I don't expect you to do this, but if you did, that's awesome, that these are all multiples. The answers are occurring every 180 degrees. So you could shorten that and go n 180. But if you don't see that, that's fine. Just take your three answers and add multiples of the period, and then you're good to go. The quicker way to solve this question is if you remember the sine graph and saying, where's sine 0? 0, 180, 60. There's your answers. So knowing the graphs helps. We'll do for the second one, we'll use the trig graphs to solve it. The second one, B, is saying where's cosine equal to 0? Well, if you remember the cosine graph, where does it equal 0? There and there. That's 360. Halfway is 180, so that has to be 90 and 270. So x is equal to 90 degrees and 270 degrees. The general solution is going to be 90 plus n 360, or 270 plus n 360. All right. If you're doing it in rads, it would be pi over 2 is 90 plus n 2 pi, or 3 pi over 2 is 270 plus n 2 pi. All right. Only use these graphing methods if it's sine and cosine equals 0 or 1. If it's any other number, then just use the regular reference angle stuff. Okay. Questions I would like you to do are in this lesson are 7a, 8a, 9a, and 11. All right, that's it for this lesson, and the next one I will combine another 2 lessons. All right, good luck.